This is the raw material chips are made of: sand. It is made up of silicon dioxide. Silicon is the second most common element on the Earth's crust and only exists in bonded form. Complicated chemical and physical processes are needed to convert silicon into a crystalline form and make sure the crystals will meet all the requirements necessary for chip production. The final product is a monocrystalline silicon rod of highest purity. This means the rod has only one impurity atom for every 10 million silicon atoms. Silicon is a semiconductor. Its atomic structure looks like this. Each silicon atom has 4 outer electrons. There are no free charge carriers. The pure silicon monocrystal is non-conductive at room temperature. To make it conductive, small quantities of specific impurity atoms such as phosphorus are built in. Phosphorus has 5 outer electrons. The 5th phosphorus electron built into each molecule of the silicon crystal lattice can move freely. Because of this structure, the silicon phosphorus crystal is negatively charged, or N-conductive. Boron atoms, on the other hand, have only 3 outer electrons. When they are built into the silicon lattice, 1 silicon electron is missing. This creates electron holes. They move through the crystal like positively charged electricity particles. The material is positively charged or p-conductive. The transistors in modern memory chips are constructed from p and n-conductive layers such as these. Transistors are the smallest control units in the microchips. In the heart of an NMOS transistor, for example, we find p and n-conductive layers of silicon crystals. An additional layer consists of silicon oxide and acts as an insulator. A layer of electrically conductive polysilicon is applied on top of it. Every transistor has 3 connections. The middle one is attached to the gate, the electrically conductive polysilicon. If we apply an electrical charge only to the 2 outer connections, electricity is unable to flow. The transistor is blocked. Things are different when an additional charge is attached to the middle connection. The electrons from the p layer now wander toward the middle connection and accumulate at the border area between the silicon crystal and the insulation gate oxide. A channel through which the electrons can flow is formed between the islands of n-conductive material. The electrical circuit is closed. The transistor can be switched back and forth between current off and current flow, that is to say, between 0 and 1. This binary system is the basis of electronic data processing.